All right, so I want to demonstrate something. All right, it's not going to let me do it. Here we go. Wow. Hmm. Ha. Hello, everybody. Welcome to the channel. Thanks for stopping by. Was going to demonstrate the difference between this circuit and one that I make, but nothing seems to be working right now. It was just working. Oh, that's it. Where is it though? Hmm. Hmm. Oh, that's good. They're all there. It's weird. How could that have happened? Nothing like even moved. It's crazy. I didn't touch anything I shouldn't have touched. Okay, you know what I'm going to do? I am going to disconnect the triggers. See if that's what the problem is. So I have both circuits hooked up to, it's actually kind of intricate. So this is the SG circuit that I bought. Really good. Lots of resistances. 12 volts in. This has got one, and this has got one. Each got a separate circuit with a separate power supply. 12 volts in on both. And right now we're just doing a comparison, a power comparison. So if we just look at that and see how it's moving, let me get my tach meter, see if we can't just measure the RPMs. 635. I got ceramic bearings in this. Pretty neat. Ceramic bearings are nice. We'll let it run for like a minute. $8.44. So SG is pretty cool. SSG. Lots of potential here. I got the output going to these lights. That light over there is being lit up by one, and this light right here, the other one. They're 100-watt LEDs, which would be equivalent to maybe a 90 volt, something like that. Something. 1170. All right, last one. Be about 1300. 1300 RPMs after about a minute of acceleration for the SSG generator combo. Now I have to hook back up the trigger strands and disconnect the trigger strands from the SSG. There's one, and then I got to connect the power, which is these little this battery right here. I might have to change where the tripod's going to be. There we go. It's a pulse motor. currently is the 9 magnets in the middle. I'm running SSG circuits right now, or I just did. And now I am going to hook up my circuits. And we got what I call standard generation, magnetic induction generation. So this is just from magnets passing by. Like, I don't have those lights hooked up, but I'll hook them up. Got about 5 LEDs that just are bright as hell. I might actually just hook this light into it since I'm disconnecting the SGs at the moment. Now let's give it a whack. See if it'll run. Actually, man, that is. Oh, dude, my bad. There it goes. Let's turn this one off. Now let's turn this secondary one on. Sorry that was messy. I'm sorry about that, but it happens, especially here a lot. So that's 12 volts on the secondary strands. These are both trifilar coils. So they got 20 and 22 and 32 over here. And then there's 18, 20, and 32 over here. 32 is a trigger, 18 and 20 are the main drives, and then 20 and 22 are the secondary drives. We're now currently running just the secondary drive with my circuits, which are basically just this right here. There's no resistor at all. It's just a battery, transistor, and 1, 2, 3, 4, 5, 6 clips, 7 clips. All right, it's over there. Sorry about that. Let me look over what you put down there, and I'll check it out real quick. 1200, 1300, 1400. I'm gonna cut it back. I was just trying to. I think with a diode, any of that stuff is kind of possible, at least a little bit. Just as long as the energies don't get commingled until they're absolutely like have to do that. But all right, let me see here. I got the first three. Let me look. There we go. Yeah, definitely using magnetic fields. Yes, two outside power sources. Actually, in this setup, there's 4 separate power sources. Can produce this alone with just the coils that are out there can produce about 400 volts, but less than 300 milliamps of current. And it's got a soft iron core, solid soft iron core. So I mean, it just without the current, it doesn't really matter. I mean, I can make it do stuff. I can make it light a light bulb, but I've always been looking to go beyond lighting a light bulb because I see everybody lighting light bulbs, and electricity is used for so much more than just illumination. And I'm trying to do something different with it, you know. The point of this device, I'm not going to lie, is probably to see how much speed I can get off of 12 volts and the way that I built it. That I got into this stuff the wrong, like, just think of Jimi Hendrix. He learned it upside down and backwards and ended up being just the bomb. You know, he's good. And that's where I'm at, man. I learned it upside down and backwards. I don't really have a point. I mean, it does what it does, and everybody knows what it does pretty much. It generates electricity using magnetic fields. And SSG, it uses the collapse of the coil as well. I can get these lights lit up brighter than they would be if I plugged them in up here, like way brighter. Thank you, Spartan. Really appreciate it. I love trying to explain what I'm doing. It's a lot of it's in my head. All the math is in my head. I don't write any. This is it right here, man. Let me show you. For a schematic, that's about as good as it gets. And that's for my sculpture, my magnetic sculpture. It's a coupling sculpture. So it uses magnetic coupling. It's like a oh man, yeah. Actually, due to what happened on my birthday. Thank you, Old Man Builds. Thank you, sir. I'm taking a lot more. I'll let it go 1500, but I mean, look at what 2800 RPMs did to this rotor. The magnet just like flew out, and then after that happened, the rotor flew off and bent the shaft. I mean, just think about what it takes to bend that. And that little disc there created it. It's hollow plastic. That's amazing. That is freaking amazing. So one safety precaution I'm taking is I'm upping my shaft to 10 millimeters, from a 1/4 inch to 10 millimeters. So it's got a lot more to it. Another thing I'm doing, all my rotors are going to be 100% infill. Yeah, definitely. The material, and it's got to be either PETG or one of the metallic infused. The copper is really strong, actually. It's actually really strong. Yeah, I'm upping my walls to 4 instead of 2 as a precaution. I'm making a lot of different changes, especially in the engineering of the whole thing. Yeah, it is a game console. Thank you for recognizing that this is a toy, and it's for me to gauge certain things. It's an adult toy. You know what I mean? There's dangers involved here that I wouldn't, honestly, after what happened the other day, I don't even know. Oh yeah, man. My favorite game actually ever made was for PlayStation 2. It was called Gladius. And when I played that game back when it came out, I was like so blown away by the whole gladiator thing, man. It was awesome. No, the cap bank. I did have a cap blow up on me though. It was 100-volt, 22,000 uh, microfarad. It was a polarized one with like 3 inputs and 1 output, and I accidentally clipped them both together. Oh my god. Now if that cap bank like popped on me, I don't even know, man. That, I mean, it's goodbye to my hair. I mean, when that 100-volt popped, I don't even know, man. I went like this. I went, just made sure my face was still there. Yeah, man. That's the cap bank. I've seen the casings that they make for the cap bank, and I definitely need to invest in one of those. Well, honestly, right now I'm making electricity. Everything else is pretty much on hold or already made. All right, where is that? Here it is. Okay, this is my. It's not really a generator circuit until I hook up the SG extension. This is my drive circuit. Hopefully. All right, and then there's another one on the other side. Grats on 6,000, old man builds. Grats, man. Way to go, dude. Way to pick it up. You've been showing me a lot of interesting things. I don't know. I shake a lot, so I don't know about getting involved with high voltage just yet. So we'll see, though. Making a Tesla coil seems like a fun thing to do. Uh, oh, see, but this coil is a lot like fatter than this one. There's a lot more wire in this coil than there is in this one. So it's a little unbalanced in that way. But yeah, I keep trying to keep it balanced by inputting the same amount of voltage into both sides. It's not perfect because the only reason it's like that is because all these pieces came from other motors that I built in the past. My mom writes novels, man. My mom is a fucking genius. She's so awesome. Oh man, you do know what solo means, right? No, there's nothing. There's no problem here. I yeah, that's what I'm doing. I'm just generating electricity. I mean, my rotor does have like a nuclear design on it, but that's all that is like a design. Like 120 degrees. So yeah, man, I have three of these 12-volt battery packs, three power supplies. I mean, I could hook up this whole freaking table parallel with power. Actually, I have two SLA batteries that I'm waiting to charge up. Yeah. So this let me describe the coils real quick. This is a one it's got a 20, 22, and a 32 gauge coil wrapped parallel. Um, it's wrapped attraction way, so like you could do 100 one way, and then you go back with two wraps, and then 100, and then back with two, and 100, and then back with two, 100, and then back with two. So all your layers are facing the same direction. Uh, did that with all these. They're counterclockwise wraps. Um, I think this one here is about 3,333 turns altogether of all four strands, or three strands, my bad. This one is 666 turns of 18 gauge, 20 gauge, and 32 gauge wrapped in parallel. Uh, Look, man, Solo, I'm trying to give you a chance to stick around, but I guess I don't even know, man. Yeah, I understand. This is not for kids. It's really not. Sorry. I am so sorry. I haven't done that in so long. Sorry. Hmm. Looks like there's a smudge on the camera. It's a little better. Okay, good. I'm glad because yeah, he was kind of like getting on my nerves a little bit. I mean, I did stated it was not a kid's thing. Pretty sure. All right. All right. So let me just make sure I get this connection right. Red. Uh, Here it is. But the SSG circuit generates so much more electricity than mine does. At least without the extension, for sure. It charged this cap in like 3 hours, and that's 500,000. I mean, it literally did like a tenth of a volt in 10 seconds. I only know a handful of devices that can do it faster. The Jewel Thief. There's some new experimental things going on different channels. I heard about Lightning Thief. Pretty sure it does something similar. And then a Bolt Robber. I think all those things can charge up a cat pretty quick. I mean, I'm not exactly sure what they do even, but I know that they amplify. So, like if there's a potential and the way that we do things only taps into a certain level of that potential, there's all this up here that other means can be used to tap into. Uh, huh. I don't even know. I don't know what's going on here. No, it's just totally non-responsive. It was just running too. I don't know what I did. I lost track of what I was doing. There it goes. There it goes. Yay. I don't know what I did. I just hooked it all back up and voila. All right. So maybe we can get all four going on the two trigger strands that we have. Yeah. Woo. All right. Now, then we move this into place. All right. I'm just going to plug this big light in. We'll see if we can get the big one lit with the generator coil. Now, it's going really, really slow because the SG and my circuit are fighting with each other right now. But watch what happens when I turn off the SG. All right, it is lighting the light just from this coil right here, the extension. See, but look at how less, lackluster that is. It's not that bright. We got a little bit of illumination there. I'm going to turn off the SG circuits real quick. Oh, the batteries are dying. Haha. I have to charge these up. If the amp draw is higher, the batteries die so much faster. Man. And then having both circuits on the same trigger strand is tricky too. I gotta plug that light. Back in. SG does not like not having an output. So you gotta have some sort of output. Look at that. That is freaking crazy. Yeah, there. Um, Something's still not right though. What is it? All right, this is what we got. This. All right, let's get our trigger. I think that's what it's going to end up being. Our trigger is not hooked up. Maybe it is. There we go. Hello, hello. This is a pulse motor. It's a electricity generator, pulse motor generator. And currently I'm working out the kinks. It was running really good. It's running kind of good now. It's half working. Let's see if it's all the way working. I don't think so. I think there's something wrong with this. Might be the transistor. And that could be possible. I had 4 different inputs of 12 volts going. Something might have happened. Wait a minute. Man, I'm a putz tonight. Watch it be this. Yep, there it goes. Whew. Then I got toggle switches everywhere. If I need to cut the power, I can cut it. Now, I'm going to plug in one of these halogens since it's getting up there a little bit. I don't like that. All right, I lied. This one needs a toggle switch. But see, with the trifilar coils, there's so much you can do. You can hook up the third strand to light, light bulbs, or you can, hook up the third strand to charge a cat bank. You've got lots of options. Well, that's two options. You definitely have those two options. All right. So I'm going to take that the 90 volt neon light that we like to use with the SG. I got a spare one right here. I have a feeling this will be lit up fairly easily. Nice and bright. Just from the motion, everything's off right now. We get nice illumination from that third coil up there. And that's the 90 volt light. See, now it's getting dim. The 12 volt light, I got a bunch of those, and those will stay lit until the thing stops, basically. So that's pretty cool. Let's see if we can get this halogen light to light. We'll have to turn it back on, but this is a 120 volt incandescent bulb. So this has the little filaments that you got to heat up to make it work. So it's 120 volt incandescent halogen bulb. I think. I might be totally using the incandescent word wrong, but you know what I mean, right? Hello, hello. How could it be used as a bomb? You're the terrorist. Why do people keep saying this can be used to make a bomb? Why do people keep saying that? Anybody else? Where am I locally anyway, guys? Where am I located locally? Man, what a fruitcake. Yeah, but if the authorities come here and tell me to shut down, I'm shutting down, no doubt. But I don't think that's fair. Yeah, if you're going to make me feel uncomfortable like that, you're the fucking terrorist. Okay? Now I have 2.5 years, maybe 3 years of stuff that I've posted. None of it's a fucking bomb. Go take a look yourself. Yeah, wow. Call me a terrorist? Jesus. Oh my God. Thank you for vouching. Uh, I don't even know, man. Maybe somewhere down the line, all this stuff and different configurations and everything, whatever. But I don't know any of that. I don't know none. I don't even really know. I mean, ask people. There's a lot of math involved in doing this the right way. I don't do any of that. So maybe, I mean, I've always thought about that. I still think about it. I mean, I gotta be a lot more precautious than I have been. Uh, if I'm going to continue to do this, I need to eliminate the fire hazards because I mean, my circuit right here, that's a fire hazard, no doubt. Uh, there's a, and it's not really about like making fire. I mean, there's a small chance with the voltage that I use in my awareness that there's going to be a fire. Small chance. I mean, and it's a very small chance. And if there is a fire, I will fucking put it out. I am the master of fire, man. I will put it out. Gotta know. Well, man, he really like, yeah, I'm using magnets and copper wire and electricity to generate more electricity. Now, the way that I see it, you got two ways that you're generating three ways, actually, three ways that you're generating electricity up here. You got your coil right here, which is an induction coil, magnetic induction. So every time the magnet passes this coil, it will generate a burst of electricity. And I can get that up to like 250 volts, maybe more, 270 of DC electricity. And it can generate up to 300 milliamps of current. So, and that's just with magnetic induction. That has nothing to do with electricity and SG and all that stuff. Nothing to do with that yet. Then I got the trifilar coil. Okay, it's got the 18 gauge drive and the 32 gauge trigger, which interact with one another. Every time a magnet passes, the trigger, opens up the gate for the transistor. Okay, so it opens up the gate for the transistor, and that interaction between the two generates a transistor, no, a transformer uh, interaction between the third strand and those two strands pulsing. So you get the EMF, you might even get BEMF off of that second coil or the third strand. Okay, so that's the strand. And then you got the output of the SG circuit, which is over here. And that's what was lighting that light so brightly. And that also comes from the collapse of the coil, or what I call the interaction, because you don't get an interaction, you don't get that coil collapse without there being a trigger wrapped in with the drive. Because when you take the trigger out of the coil and you put it so you can put it somewhere else, you don't get that harmonic chirping that you do when it's inside with the drive coil. It's different, man. It's 100% different. You might get more speed because you can maneuver the coil to get the best position, kind of like a reed switch. But you don't get that extra boost you don't get the output. You don't get the output, and that makes it totally different. Now you will always get that extension, and maybe the output is the extension where you connect the collector to a collector, or you attach the collector to the end of your coil. Whichever, if your coil comes first, you attach it to the coil. If the transistor comes first, you attach it to the collector. Just like that. And, I know that's basic stuff, like figuring that out, but I love that I figured that out because I can do stuff now that I couldn't do before because there was so much resistance involved in some of my coils that I couldn't even make stuff work even a little bit. But now it's like, yeah, man, I've come so far and like figured out so much stuff. And then there's like, this is just in the pulse motor kinetic magnetic field. Just this, I've figured out so much. And yeah, it's one thing to have a caucus about it. It's another thing to get your hands dirty. And then it's a totally different vibe when you do both, man. When you actually get a group of people together, talk about it first, plan it out, and then build it. That's a totally different experience. It's like, it's a good thing. But like me and my buddy Dollarath, haven't heard from him in a little bit, but I've been trying to get back in touch with people. This rotor, look at these gyros, man. They flip, flop, and floop like crazy. I am not an electrician. I'm an artist. I like to paint. But people that have been doing this for years have counseled me. I want to give a shout out to Peter Hall Effect 2.0. Old Man Builds comes by and drops pearls every once in a while. I try to capitalize on those. Benefactor, he's doing some interesting work with rodent coils. Let me think here. There's this, I forget what his name is. But he's the one who actually how-to movies, how-to videos on making rodent coil and whatever. But the two-dimensional ones, like the star coils, or the 12 pointed and 36. I think it's 36. But no, definitely not an electrician. I might have been good as an electrician, but I did not put in the work to become one. Yeah, man. So why I started doing this was I asked myself, I was looking like a carousel, how do I make it move without doing it myself? I mean, I can spin it, but I shouldn't be able to have to keep spinning it. And it all unraveled from there. I just asked myself, how do I make this thing continuously spin? And then I started asking questions. And back then, people were cool, but now people are cool. But I mean, he helped you? That's freaking cool, man. In this day and age, it's like better in a lot of ways than it was back then because there's so much more people involved in doing it now than there was just 2.5 years ago. There was a guy that I was watching doing modem coil tests. He had like a bunch of stuff. I haven't heard heads or tails from him though in a long, long time. No videos, nothing. He's just poof, gone. He was studying it. I think something happened to him because that's scary. You know, he just stopped doing it, and no head, no view, nothing, just gone. And I guess it's okay. I mean, people probably do that all the time. Stop doing their YouTube stuff. But I mean, yeah, playing with the high voltage when people just disappear, it's like, wow, something might have happened. And now what I've also learned, and I don't know if this is right, check me if I'm wrong, anything above 5 volts is considered high voltage. Is that right? I mean, yeah, it's funny. People do that all the time. 1,000 volts. Okay. Yeah, man, the most I've ever done is like 295 on one of these little buck converter transformers. They go up to 395 DC to DC. But I just put it up to 295 and it broke. It just popped. It was too much for it to handle with the coil that I had it hooked up to. I guess when you're dealing with an Arduino, though, 5 volts is the voltage, right? Maybe that's what I'm confusing it with. I just kind of remembered that. So thanks. So 60 volts. Okay. Or do you use a barrack input, or how do you do that? Okay. Cool. So that's definitely going to be something that I'm going to invest in. Is the AC output module? Well, input for the stuff, but output for the power. Yeah, I need one of those. Uh, Peter, I'm worried about Peter too, man. I don't even know. It's my nature. Maybe they just don't want to deal with me and my drama, but I can't. It's not going to stop me from wondering if they're all right. You know, Peter and over Unity Research Channel. I haven't heard anything from him. I hope he's okay. He was about to have a kid. Just I hope everybody's all right because I'm all right. I mean, even if the police come knocking on the door, I'm going to be all right. Because I'm reasonable. That's why I'm reasonable. I'm not going to sit here and start dancing a jig when the police knock on the door. No, I'm going to be like, all right, I'll take it down, and that's that. But I shouldn't have to say more than one time to this guy, if he's a reasonable person, that it's not a bomb. Is that 0.15 or 150? 0.15, so really, 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 really small ones. Okay. Well, I do have something like that. They're 50 volters, but their capacitance is like 2.7. This little baby right here. Is that something like, or are they big? Are they AC? They're probably AC caps, right? Fifty volts is too high, or 2.7. 2.7 is too high, and that's really low. Oh my god, that's a very specialized cap, man. Very specialized. What? Okay, they're the big ones. Okay, yeah, I gotcha. All right. Cool. Let me show you what I'm thinking about. I don't know if this is like where I need to be with that, but I just looked at this and I'm pretty sure this isn't right. But for a foundation, for a Tesla coil, like a former. Don't know if that'll work though. Very thick PCV. Well, it's normal thick. PVC. Don't know. It says 1.5 inch, but that's the diameter of it. So this won't work. This is 1.5. All right. No, it was 1.5 inches. Oh, all right, right. I mean, I have this little cap. I call it like the cap buster because it is a Tesla coil, but it's in a format that is not standard at all. It's supposed to dance to the music and everything. 63 volts per cap. So there's your 60 volts. Yeah, that makes sense. So the really small caps would be 60 volt caps with the minimal capacitance, right? And yeah, this is just a little cheap thing I bought on Amazon. Very cool though. I would equate it to one of those ionic balls that without the glass. So here, food for thought. I think we can use or utilize a certain size Tesla coil to create a bubble way, which would elevate the current infrastructure one level. And literally, you have the energy from the Tesla coil resonate within something you would put on the bottom of a vehicle, or maybe even attached to the wheels. And you should be able to like basically levitate on that field when the two fields interact with one another. And it shouldn't matter how much it weighs. It shouldn't matter at all how much it actually is putting down on there, because if you know what I mean, it'll work. It should work like wonderfully. We just have to make the right kind of coil that will actually create a force that will repel the equal and opposite, not opposite force, but same force. So like north to north, basically. I get it. I get it now. It'll pop very fast. Yeah, I'm great. How are you doing? Trust all is well, Emmanuel? Well, right now I'm having a chat. What are you doing? This is a pulse motor if you want to know what I was making. It's a pulse motor. The DC brushless motor that spins. It generates electricity too. Yeah, I mean, if the Tesla coil can generate a field strong enough to repel the same field, we can fly. And there's nothing that can stop us from doing that in our atmosphere without needing jet fuel or tremendous amounts of speed. We can coast like pimps on another level if we can get this right. And what really, 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 really got it going was I call it a vision, but it was just my imagination going wild with a tricycle. You know, those motorized tricycles are really fat and they got the big, wide tires in the back, two in the back, one in the front. Tricycle. But this freaking thing can fly. This tricycle can fly, and it has, you know, adjusting, rotating wheels. All we need is that to implement, not just to illuminate, the road, but to, and I think if we could combine the Tesla coil technology with solar roadways, right there, man. I mean, just the endless possibilities, man. I could talk all day about this stuff. And I really, 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 really think the Tesla coil can be used in our infrastructure to elevate the road. Become several Tesla coils lined up, And if it's in solar roadways, man, the roadway itself will power the Tesla coils. And there'll be batteries in the road. There'll be large, batteries, capacitors, whatever you freaking need to make everything work. Be right in the road. And, they're making the glass so that semi trucks can drive on it now. But solar roadways, definitely, you should check that out. That's a real thing. Um, I'm sure they're always, willing to accept support. Um, really, really cool stuff, though. Just think about it, man. A road that can take a load off of the grid, like instantaneously. We just got to get the cost down, and I'm sure we're heading into that era where so much automation is in place that the cost is going to be next to nothing if we can just be honest about what's going on. The only reason things cost so much now is because of capitalism. It's like, yeah, we can afford to lower the price 50%, but we're not going to do it. That's going to hurt our bottom line. That's capitalism. Everybody knows this. I say lower it 35% and everybody will come to you instantaneously. Then you win because you've just gotten all the competition to come to you. And, so you don't get the entire 50%, but so many more people are coming to see you that it doesn't matter because you're already making more money than you would have if you did nothing. Capitalism. Equilibrium. That's a word that I really, really like. Equilibrium. Where everything is 0 point, man. That's it right there. Being able to, because everything is energy. Everything resonates in and of itself, and the energy, frequency. There's sound, light. All these things are energy, and to be able to harness that or tap into just the abundance in nature. Talking about having the mastery over your own environment. That'd be sweet. And I've been thinking also about maybe growing some plant. I have a lot of iron filings that I'm thinking about growing a cactus in iron filings. See what happens. Because I'm almost positive there used to be wood on this earth that isn't here anymore because it's been all used up. But definitely like grove wood that grew on iron deposits. So it's not only magnetic wood, because over the years the trees would seep up, the ferrous material. I'm not sure exactly the bottleneck of molecule size that the roots have, so I don't know if this will work. But I'm pretty sure that in our Earth's history, we've had some stuff that just doesn't exist anymore. It has to be recreated. And the ironwood is definitely one of those things, because I'm almost more than positive that, you know, like frankincense, man. People say it's like this, but I don't think frankincense has anything to do with this. I don't even know what it is, but I'm pretty sure that you know, it was what's that, like in, I'm not sure exactly what I'm getting at, but the movie Noah with what's his name? Russell Crowe played Noah, and there's that flint spark, that plant that is like electrified, and I believe solely down in my core that stuff like that existed, and it's not made up. Is that a serious question, Christopher? Or are you just causing trouble? What's up, bro? It's not empty. I'm not going to spill it. Good observations, though. I don't know how to address that. Uh, it's like people that have a brain and they like use it for stuff like that. This is my work area. I have like 360, well, 270-degree around my work area. And I'm pacing right now because I'm on a roll, man. I'm talking about stuff. I'm not even really pacing. I'm just walking around in a circle like you suggested I did. Is that better? How's that? Is that good? What's up, man? How's it going? You good? I'm good, man. Cool. I am the circle. I am one with the circle. It's a straight line if you unravel it all the way. Well, um, I've did it. It's a pulse motor. It's got ceramic bearings in the rotor. This rotor weighs about 4.5 pounds. It's solid plastic. It's one whole roll of filament, so that's 2.2 pounds. And there's 9 neodymium magnets in it, so that's another 1.5, 2 pounds. So it generates enough electricity off of this coil to light a 100-watt LED. It generates quite a bit of electricity off the SG circuits. Do you want me to turn it on? I can turn it on. Turn it up to 12. And I'm like, how do I get this thing to spin without me doing all the work? See, now this light's lit up now. This light's lit up now. Let me turn off the headlight. Here you kind of see, we've got two SG circuits here, illuminating the light that can charge the cat bank, which is right there. I'm not doing that right now, but yeah, that's good. And then this is an induction coil, magnetic induction. When the magnet passes, it creates a spike, lots of spikes. There's 18,000 turns of 32 gauge in this coil. And I just don't have it hooked up right now. Let me see if I can't get, because I know the neon light will light up like pretty easily. I want to get a halogen bulb. There's one. So this is like one of those old school light bulbs. Oh, it's already hooked up. Okay. And it looks like it's not going to light it. Let me move it in. See if we can't get it lit up. See, it's really hard to get lit. It needs current, I think. See, that's not lit. Needs more current. Let me hook up the... Look at that. Woo! That's the 90 volt one that goes with SG pretty much. I'm going to turn it off because it's getting loud, and I just had a catastrophic failure. I'm going to show that to you guys. Nuclear reactor is old school, bro. That's literally like the last war. World War II or something. I don't know. And I'm not that smart. I'm not a nuclear scientist. Oh, I got about 10 minutes, and I got to go get my daughter from class. So what do we want to do in those 10 minutes? Oh my God, dude, this stuff thrills me to no end, man. So, I mean, this is funny you should say that, Muscle Hut. I used to know this girl that spoke about this stuff like it was my passion. I didn't even know. I had no idea. I paint stuff, so I mean, like this. You know, I paint stuff. A catastrophic failure. Let's show everybody what that is. Okay, 3 neodymium magnets. One forced its way out at 2,800 RPMs. So the magnet went flying one way. And of course, at 2,800 RPMs, the rotor went the other way. Thanks, Luke. Yeah, man. Look at this shaft, dude. It's a 1/4 inch of like stainless steel. Yeah, man. Anyway, now ever since that happened, and I've had to throw them. I've had magnets go chuck before, but nothing like this, man. That shaft is it's bent now. It's never going back. uh, hell yeah. But I love this rotor because, I mean, it's been off now for like 3 minutes. Yeah, it's so much force. Actually, it's a lot of, it could have been a lot worse. This is like light as a feather. This rotor is so light and it's like hollow. It's worst thing I could have done. Oh, that's okay. That it's got an iron core in there. Solid iron core, soft iron. What's up, Luke? Yeah, I know, man. It was going to go for quite a bit longer, but the damn coil. And I mean, I said to myself, I'm gonna like, well, I don't even know. I should probably glue it down, don't you think? Get it up as close as I can, and then glue it down. I don't know. Maybe. I got these big zip ties that I could use, but the holes aren't big enough. Oh, let me show you what I'm upgrading. Upgrade. 10 millimeter shaft instead of the 1/4 inch. So it's quite a bit fatter. And then I'm going to get a base that makes sense, not pegboard. Yeah, when you get it up really close, then miraculous stuff happens as long as it continues to spin at speed. Anyway, I think this shaft is going to work a lot better, this size anyway, and I'm going to have to change the base because it won't fit in the holes. It's probably a good thing that I need to change the base because lots of bad things have happened using. That's right, more sturdy. And I do have a piece of plywood under here and a 2x4 down the middle, but there's space. It's ridiculous. Yeah, it's definitely going to upgrade. Oh, and then I have 1/2 inch shafts as well, but I don't think I need all that. I have some acrylic 1/2 inch. I might do some of that. What, 10 millimeters? I don't know, maybe. Yeah, I got 1/2 inch though. I got a 1/2 inch. It's very magnetic too. Oh my Lord. Thank you all. Really appreciate it. I got to keep looking at the clock though. So, about 15 minutes. So what I'm going to do here is I'm going to disconnect the 22 gauge strand and the 20 gauge strand over here, and I'm going to hook a light up to both of those, or I might hook the multimeters up to those strands. That's what I'll do to see how much AC is coming off of each one of these in the trifilar coil. Well, it'll be better than a 1/4 inch for sure, and it'll give me the opportunity to explore my ability to build a little bit more. Because right now, 1/4 inch hole, 1/4 inch pole, 1/4 inch bearings, everything fit into a 1/4 inch until that happened. Now, for generation purposes, I did do a little bit of that. I took down some running at 5 volts parallel. So 3 coils running at 5 volts. Took down the readings of how fast the cap bank was generating. And there was a half-hour test per example, and I did two different examples with 2 different rotors. So I don't know, I'm just getting into writing stuff down. Right now I have a video library. Hey, Carlos. This is a pulse motor, and right now I'm going to hook up multimeters to the 3rd strand in my trifilar coils. I know that sounds, well, to some people that's, days at the office. For some people like me, I don't even really know what that means, but we're going to do it. So this is the transformer coil. Huh. Now that is perma on. Why is that perma on? So about 13 volts is coming off of that strand AC, but here, now let me look at it. 7.9, 8. So you're getting magnetic induction, but you're also getting a transformer effect. That's a 20 gauge strand doing 8 volts. That's pretty damn good for how fast that's going. That's awesome. All right. Have you ever made a bomb? This is not a bomb. Sorry, Cairo. Dude. I'm going to report you for knowing how to make a bomb. All right, but I think I gotta go. I'll be back later, guys. If you want to come back later, I'll definitely be doing stuff later on. Well, thank you very much. Thank you. I really appreciate those who have something to say, man. See you later, Luke and Carlos. Adios.